My name's Bob Flynn. I'm the senior instructor here at Palo Alto Networks. And today we're going to be talking about routing. So best practices for routing with Prisma Access. We're going to talk about the routing we do in the cloud within Prisma Access with eBGP between the different nodes. We'll also talk about a couple of routing options that you or your customers can have for our default routing infrastructure, or leveraging your own or your customer's own static or probably BGP implementation with what we call hot potato routing. We will talk about the routing between the default routing protocols that we use and static routing between the corporate access nodes and the RN-SPNs and the MU-SPNs. We'll talk a little bit about integrating BGP. So integrating your probably existing BGP implementation and having the Prisma Access nodes join into that. And we'll also talk about traffic steering, policy-based forwarding, policy-based routing. You may have heard these things, these terms before. This is basically the Prisma Access version of that. There will be opportunities to ask questions and get those questions answered. Please use the QA function versus the chat function to do that. We will answer questions most likely at the end of the session here. If something pops up that might be interesting in the middle, we may diverge a little bit and talk about that. But for the most part, we'll save the questions and answers for the end. So again, thanks for joining us. Let's dig in here. So Prisma Access, when we talk about routing, we can basically take all of those topics we talked about and put them into three categories. An overview of the routing, including our internal routing, the different routing modes, the hot potato versus the default routing, and traffic steering. One thing to understand is that between all of the different nodes, all of the mobile user SPNs, between the corporate access nodes, the service connections, between the remote network SPNs, we run our own BGP, eBGP infrastructure to get you between the different nodes as quickly as possible, provide fault tolerant routing, give you the ability to be able to reach all of the different nodes which are deployed in high availability without any sort of configuration involved on your part or your customer's part. We do it all internally, and we manage and take care of all of that. For routing between a mobile user and say a branch office, a remote network, or between one remote network and another remote network, you do then have the ability to be able to route using static routes between, say, one remote network and another one, or a mobile user going to a remote network, a branch office. And again, we have a couple of different routing modes, the hot potato and the default routing that we can do for that. So that's what a lot of this is going to be talking about today. Between the different remote networks and the corporate access nodes, or between one remote network and another remote network, we can use static routes. Traffic can go straight from one remote network to another without having to traverse a corporate access node. If users need to be able to access services down a service connection, then certainly we can do that. And that might typically use the static routes to do that. To be able to talk between one remote network and another one requires some licensing. By default, users in a remote network, in a branch office, if you will, that are going through Prisma Access would go straight out to the internet because that would be their most common destination. But if they needed to reach some sort of a authentication service or DNS or something like that in a data center, then of course they can use a service connection, an SCCAN. And typically you would use static routing to say, if you're trying to reach this DNS server at this address, hey, use this static route and go through this corporate access node. You can have multiple corporate access nodes in a deployment. And if you have a global deployment on multiple continents, then chances are you would have more than one corporate access node. You may have one in North America, you may have another one in Europe, another one in somewhere in Asia, something along those routes. And a user in a remote network, user sitting at a branch office that needs to say authenticate to a server or use multi-factor authentication going through a data center would go through the closest geographical one to them. If they don't need those services, they would go straight out to the internet to go to their destination, maybe they're going to browse the internet, or maybe they're going to social media, maybe they're going to something like Salesforce or their Gmail accounts or whatever that case may be. They would typically go straight out to the internet through that remote network SPN, where we can do all of our traffic inspection, threat protections and security policy rules and decryption and all of those sort of things that you would expect with PAN OS. Mobile users, in order to reach a remote network, have to actually traverse a CAN, Service Connection Corporate Access Node. That is their router that gives them internal routes to get to one remote network or another remote network. By default, a mobile user would just go straight out to the internet. That would be their most common path, is again, reaching something not on the internet. But if they need to talk to a user in a branch office or something like that, we can use a corporate access node, SCCAN, basically as a router. Now, instead of them going down that service connection to say authenticate or get to whatever sort of resource they might need internally, they can just bounce through a CAN and use it as a router. Which brings up an interesting scenario. If your deployment is all in one region, basically a continent, if you think about it, then you may have a primary and a backup data center, and we would use the one that is up and running. But if you have a situation where you have multiple regions and deployments, say in Europe and in North America and things like that, it makes sense, even if you only have a single data center in one region, say in this case in say North America, it makes sense, even if you're not going to use that corporate access node as a service connection, to deploy another one close to where your users are. Why is this useful or important? Well, let's take a look at this. If I had a mobile user that, say, needed to authenticate to a data center, they're in Europe, data centers in North America, they're going to go down that service connection to that data center in North America. Then, they'll go straight out to the internet or what have you. But if we have a mobile user that needs to talk to somebody in a remote network near them, remember, they still have to use a corporate access node as a router. Well, that would be a pretty long round trip to go from a mobile user in Europe through a corporate access node in North America over to a remote network in an office that's just in Europe, that's just, close by. So it makes sense to decrease that latency because that mobile user has to go through that corporate access node, has to route through that, has to use the routing table to get to that remote network. It makes sense to deploy corporate access node close by, even if there's no service connection. For instance, we do have a service connection here in North America for, say, our authentication servers and things like that. Even if you're not using that corporate access node for a service connection, it makes sense to have them close by your mobile user base if they need to be able to talk to users in a remote network in a branch office. This is going to give you much better performance when that mobile user is talking to the people in the branch office in the remote network. It's going to reduce latency, and you can simply use that corporate access node basically as a router, as your internal router to get traffic back and forth. When it comes to routing, basically, we can choose our default routing model. Now, the default routing model uses the Prisma Access backbone with all of our best path selection mechanisms and our eBGP routing that we control. And this means that you can rely upon fiber optics and high speeds and things like that. But there will be some occasion where you or your customer may be interested in using an existing BGP integration that maybe joins up multiple branch offices, and you want to be able to route through your existing BGP implementation between branch 1 and branch 2, remote network 1 and remote network 2, if we're talking about Prisma Access terms. And we can do that also. So you have this choice. You can choose to use the default routing, which uses our backbone, or what we call hot potato routing, which uses your backbone. So the way this would work is that, let's say I had a mobile user in the United States, or a user in a remote network in the United States, in the US, that needed to talk to a user in Europe. The default path using our default routing, or cold potato, as some people call it, would be that we would go through the remote network SPN. We would have routes, either static routes or maybe BGP routes or whatever the case may be, to take you to the RN-SPN in Europe through our own backbone. And then you would go down to the user in that other remote network. So this would be our default routing usage. If there is an existing BGP implementation inside your infrastructure that you would rather use than our default routing, if you say, well, you know what, we've got all these static routes or BGP routes, and we've got our own infrastructure, and we got great big routers, and we think it'll be faster to use our infrastructure than it might be to use Prisma Access's backbone, then you have the ability for a user to basically, again, if we have our user here in the US trying to talk to our user here in the EU, we can bounce that remote user off of a corporate access node, a CAN, back down into the internal routing infrastructure to be able to get to, say, that user in Europe in that remote network. So you got this choice. You have the ability to use our stuff or your own stuff. We do have a question or two here. Let me just take a look at these real quick. Does internet traffic from headquarters go through a service connection? Somebody had a great question here. Users inside my data center behind my corporate access node, are they going to use that corporate access node to get out to the internet? Actually, the corporate access node, that service connection, is designed for Prisma Access users to be able to access internal resources. It is not used to egress out to the internet. The idea is that a corporate access node, that service connection, would allow users to get into, say, a authentication server or something along those lines, but they're not going to, we assume that there's already in a large data center, a big firewall, some existing way to get out to the internet and egress to the internet. So we do not need to provide that. There is a configuration where we can actually deploy a RN-SPN, a remote network SPN, to be able to firewall people going out to the internet using our infrastructure and allow people in through that service connection or the equivalent of a service connection if we needed to. But from a data center going outbound, we assume this was existing infrastructure. We assume that you have some sort of security stack. You already have routes going out to the internet and stuff like that. You're not going to be ripping and replacing that. You're going to use the existing stuff. We're going to augment these branch offices, and there's remote networks where you did not have any sort of security. You were backhauling those users through that data center, taking them the long way around to get to the internet. Well, the remote network SPN gives you the short path to get to the internet, but you would typically leverage your existing infrastructure for your users in a data center, or maybe a large headquarters or something where you already had this infrastructure. No need to rip it and replace it. Somebody was asking for the hot potato routing. Is there a need for the remote network add-on? Yeah, what we call the interconnector or the remote network add-on, to be able to have one remote network talk to another one. That would not be necessary if you use the hot potato routing, because you're going to be leveraging your own routing infrastructure, which means traffic is going to go down that service connection to a data center where your, say, iBGP or even eBGP infrastructure is that you've created. And so you do not need our add-on in order to do that. Now, if you're using the default model, then yeah, you would require that add-on in order for one remote network to talk to another one, or a mobile user to talk to a remote network. Or the traffic would go out to the internet, long way around, back in, and to the remote network, sort of circumventing Prisma Access on the way back in. So hopefully that answered those questions. So the hot potato routing goes down into the customer infrastructure, uses their existing routing infrastructure that they may have already built to talk, for branch 1 to talk to branch 2, or headquarters to talk to branch 1 or branch 2, or whatever the case may be. And the default or cold potato goes up into our backbone and we route it. The setup for the routing is done as you onboard or build these remote network instances, these remote network security processing nodes. There you have the ability to choose static routes or BGP. There's also QoS, but we're not going to talk about QoS today. You would either add network definitions, say I've got an internal IP address range of 192.168.1.0/24. I got another one that's 172.16.0.0/16 or whatever the case may be. Or you would go into the BGP tab, and within the BGP tab, then you have the ability to designate your ASs and be able to do things such as set up all of the peers and IPv4, IPv6 addressing that sort of a thing, those sort of things. If you are going to use BGP, then it's important to understand the status of your peers. Hey, are my BGP peers talking to each other? Am I joined in? Am I getting updates, routing updates from my peers? Am I advertising routes, doing those sort of things? And you do have the ability to do that within Prisma Access once you set up the BGP peering with us. You can go into your network details. This is under the status tab. Network details and the service connections. And if you look at those service connections, because the service connections, remember, are where the routes are, you'll be able to see the BGP status. And you see the community fields and those sort of things. So this will give you real-time updates. The other big topic to talk about today is traffic steering. Traffic steering gives you the ability to be able to forward traffic or have traffic forwarding rules, what you might be familiar with on our firewalls, on our Palo Alto Networks next generation firewalls, with what we call policy-based forwarding. Or you may be familiar with other vendors. I've heard this called policy-based routing before with some other vendors. But the idea with traffic steering is we have the ability to be able to use things other than just a destination address to determine what direction traffic is going to go in. So we have the ability to do the default route traffic steering based on our default routes, even default routing and hot potato. But we also have the ability to steer traffic in different directions using other criteria. Perhaps you have traffic that would normally be destined to go straight out to the internet. You would like to force it through a data center to do additional traffic inspection, or to be able to go through an explicit proxy or a web gateway or something like that that exists in a data center. We can do that, and we can forward this traffic based on criteria other than a destination IP address. We have the ability to use these traffic steering or traffic forwarding rules, whether you're using the native routing, the Prisma Access native routing, or hot potato routing, and be able to designate different traffic to go in different directions. Here's an example. A mobile user that is, say, going out to Salesforce or Office 365 or something is typically going to go through that mobile user security processing node and then out to the internet. Perhaps you want to force that user to go through a security stack at a big data center, at headquarters, before it goes out, say to Office 365 or something like that. We can change that default route or that default behavior by using traffic steering rules. So I could say, well, I've got some traffic that I want to go ahead and send out to the internet, but I have other traffic that I want to force back through headquarters and then through my security stack and out to the internet. So now I can designate that traffic using different criteria, override that default behavior of Prisma Access. I have the ability to use things like addresses, source addresses. I'd say, hey, mobile users with an IP address of 10.10, you need to go through the data center for all your traffic. I could do it based on user ID, because remember, mobile users are going to be identified. Basically, it's built-in user ID. Once you deploy your mobile users, you don't have to deploy additional user ID stuff for those users. So we take care of users and we say, hey, you know what? If you're Bob, you go in this direction. If you're Mary or Tom or Bill, you go in this other direction. We do by destination addresses. Even so, for instance, we say, well, if you're going to Google, go straight out to the internet. If you're going to Yahoo, go through the data center instead, as an example, using IP addresses or using URLs for custom URL categories. I say, hey, if you're going out to Office on Demand, Office 365, go through the data center first. But if you're going to Salesforce, then go the other way. Or if you're going to, Facebook, go this way. If you're going to Twitter, go the other way. URL filtering is built in to Prisma Access. There's not additional licensing or anything like that for it. And of course, you can build your own custom URL categories, your own lists of URLs. We do also have the ability to do service types. Port numbers is really what it is. I can say port 80 goes through my data center. Port 443 can go straight out to the internet, for example. And I have the ability to group together multiple different service connections and force traffic down the closest one, or primary backup one, that sort of thing. And then other traffic straight out to the internet as it would normally go for your mobile users or for your remote networks. If you want to push traffic to your service connections, you create a service connection group. And that group could contain a single CAN or service connection or multiple ones. And you could, maybe have a group in the US, a group in Asia, a group in Europe, etc., or all of them in one single group. But then you have to create rules to say how you're going to steer and make exceptions to this traffic. This starts to build much like a policy-based forwarding on our on-premise firewalls do, where you're able to take information about source or destination IPs, URLs, services, i.e. port numbers and things like that. And then as an action, either steer towards that, say, service connection group that I created, or straight out to the internet. anything you do not describe is going to go straight out to the internet. And you do this by creating a rule set. And, like all of our rules and our rule sets, like security policy rules, NAP policy, or well, we don't do NAP policy rules with Prisma Access, but like all of our policy rules, we start at the top, work our way down, and first match wins. Now, this can get pretty sophisticated or complicated, or be pretty simple depending upon your goals or your customer's goals or that sort of thing. Remember that remote network users or mobile users by default are going to go straight, well, they're going to go through a security processing node and then out to the internet. Unless you have a static route to force them through a CAN. But if they're headed to say Office 365 or something, well, you're not gonna have a static route for that down your service connection. So they're gonna go straight out to the internet, as well as remote network users. They're gonna go straight out to the internet. But you could, as I said, use traffic steering rules to say, hey, you know what, mobile users, when they're going to Office 365, let's let them go straight out to the internet. If they're going someplace else, let's send them through our data center. And, maybe I have my users in one region going to one data center, another region to another data center, using those data center groups. And maybe other traffic, instead of bouncing it through the data center and then out to the internet, I want it to go straight out to the internet. So now you can make all these rules based upon IP addresses, based upon applications, based upon URL categories, based on port numbers, and determine whether you're going to send them through a data center or straight out to the internet, or divide the traffic up for different, whatever your goals might be. So in this example, what we've done is we split traffic where traffic going to Office 365 goes straight out to the internet. Other traffic bound to the internet goes through a data center. Goes through the security processing node, then to the data center. And it's a matter of writing the rules and putting them in the order that makes sense to do this. Pretty sophisticated with this. Here's an example where we said, well, if you're going to one site, you'll go straight out to the internet. A different site, you'll go through a security processing node straight out to the internet instead of through a data center. Another third category or a third site, you'll go through the data center again. And so we can split this stuff up, making exceptions or to the default routing. And the default routing is straight out to the internet. So between all these options, right, using default routes to steer traffic, all traffic through a data center, using static routes to go from one remote network to another one, using static routes for services down a service connection, using default routing and leveraging our infrastructure, using hot potato routing, pushing stuff down into your infrastructure, making exceptions and traffic steering rules, using URLs, URL categories, source IPs, user IDs, destination IPs, all of these sort of things allows you to control at a very granular level what you're doing with the routing when it comes to Prisma Access. Now we've got quite a few questions here in the